Hello guys, how are you guys?
Good.
Who has the name RJ guest? RJ, who is this person? Hello? I don't see. All right, let's start. This week is our final, last week. Okay. And the this is announcement for the week 16. So we have three assignments. There's two of them are already there before. One of them is already there before. Homework 9. So I extended it to this week, I believe. Then homework 10 and the project. On Saturday, yes, on Saturday, right? Yeah, Sunday.
Professor?
Sunday, I'm going to make the final exam available so you can take it.
Excuse me, Professor.
Yes, yes, sir.
Well, this is Cedric. I emailed you with the 5 assignments.
Yeah, yeah. I'm gonna respond. Everybody must have everything, but I've responded to some of you, but I'm doing it batch by batch. So the one I'm gonna send last Monday, tomorrow morning, you gotta get it, and it will be due. I'll give you a due date. Okay?
Okay, thank you.
Yeah. So I'm gonna make the final exam available on Sunday night, midnight, probably, so that you have, yeah, give you the time to take it. Because the school gave us deadline to submit final grade. Now the project, there's a data set I want you guys to use. I'm looking for where I saved it. So like if I don't see it today, then I'm gonna create a new data set, or I'm gonna use a different data set for it. Yeah, it's gonna be based on estimating the average using a confidence interval method. Now, tomorrow is the latest uh, day. If I must have it available by tomorrow so that you can round it up by uh, Sunday. Now, and of course, when I put it, you're gonna, as usual, get access to it from the model. Okay. Yeah, I'm gonna put it right here. Now, this homework 10 and homework 9, we're gonna finish. We started it already. So I mean, not they started it. We started hypothesis testing last week. We finished it tonight. I mean, the areas we need to cover. I'm gonna put a video for you in the announcement. Two videos. You just watch it and use it to do the assignment on their homework on regression and correlation. Yeah, they are really Excel. You gotta do it on Excel. So that's why I made a video on that. You can watch it and follow the steps to complete. I'm talking about homework 10, regression and correlation. Okay. Um, now, what else? What else? What else? Let's begin. Let's continue from where we start. We got the student that mentioned that they sent me an email. What's her name again, sir? Hello? Hello? Guys, can you hear me?
Yeah, we can hear you.
Oh, okay, okay. Yeah, sometimes my internet, sometimes it on and off, and I don't know. I think a network problem. Now, they can begin now. Like I said, we stopped last week. I introduced you to the concept of hypothesis testing. We did some we covered how to state hypothesis. Now, there are some terms I want you to know before we now proceed. First one is the level of significance. We have been here before when we are doing a confidence interval. When I explained that um, if you're 90% confident, then your chance of being wrong is 10%. That 10% is your alpha, 10% or 0.10. That is the probability of you committing type 1 error. Okay? If you're committing type 1 error, um, just your alpha or your significance level, alpha. Okay? So next is the critical region. Critical region, another name I gave it is the rejection region. If your answer falls in the critical region, you reject no hypothesis. Otherwise, if it doesn't fall on it, you don't reject. That is the criteria. Now, critical value is the cutoff value between the critical and non-critical region. Now, I think I mentioned some of the two tests. Okay, two-tailed test. If you look at this chart, okay, make it right here. Look at this chart. See the yellow part. See, do not reject. If your answer falls in this region, you don't reject. If it falls on the, you have two-tailed because you have both the left and right section data. It has critical values in both, critical region in both left and right. If your answer falls on this, you reject. If you fall on this blue region, you reject. But if it falls on this yellow region, you do not reject the null hypothesis. Okay. More people are coming in. Let's see, Sydney. Who's Sydney? Sydney. Okay. Oh, found it. All right. So because you have two critical regions, we call it a two-tailed tests. Now there's one that we call left tail, in which case if your answer fall in this, the rejection region is on the left side of the chart. Okay. So if your answer falls, you see this pink side, that's why you reject. If you fall here, you don't reject. Okay. Next will be the right tail test. See, do not reject here. If you fall on the right, the critical region falls on the right side. So if your answer falls there, you reject. Otherwise, don't reject. Okay. Now, I showed you how to get critical values when we are doing confidence interval. The only difference that the confidence interval, the critical values are usually two-tailed for the two sides. Sometimes in this hypothesis testing, you might have left side critical region or right side critical region or both sides. So these formulas, and we will be using them here to find the critical values. Okay. When we begin to use them, I will show you how they can be applied. Look for my yes, okay, right here. Okay. Now, let's look at then the z-test. We'll start with the z-test for the mean. Okay. The z-test for the mean. Now, the z-test for the mean, here. The z-test for the mean, there are two methods. The one is the traditional method where we use critical value to make decision whether to reject or not to reject. For example, in the z-test, in the traditional method, first thing you do is to state the hypothesis and identify the claim, then find the critical values using the appropriate table. For this class, we'll be using Excel to find it. That's why I put all these tables here, all these formulas here, so you can see it. Now, next is the compute the test value and then make a decision to reject or not to reject null hypothesis, then summarize the results. Now, this is the criteria for rejecting and not rejecting. Right here, it says reject the null hypothesis if and only if the calculated value is equal to or exceed the critical value. What is saying here is that reject the null hypothesis if your answer is equal to or bigger than the critical value. And this is the test statistic we use for that. Now, for the test statistic says z equals x bar minus mean divided by the standard deviation over square root of n, where S bar represents the sample mean, mu represents the population mean, delta represents the population standard deviation, and n is represent the sample size. Now, for the p-value method, that's the method here. For the method, it's basically the same thing, except the only thing that this is different that instead of using the critical value, you use the p-value. And the decision criteria says here, if the p-value is less than alpha, less than or equal to alpha, reject the null hypothesis. If the p-value is greater than or equal to alpha, do not reject. So, like I said, both methods will be using Excel for them. And let's start with the first one. First one says here, a researcher report that the I'm gonna make a space here. Okay. Right. Report that the average annual salary of assistant professors in the year 1997 is more than $42,000. A sample of 30 assistant professors has a mean salary of $43,260 and is at alpha 0.05, test the claim that assistant professors earned more than 42,000 a year in 1997. The standard deviation of the population is 5,230. Now, first thing, of course, is to state hypothesis, identify a claim. So we need to get our HO and H1. Okay. I want to make this sense to be 80, size 80. Sorry, size 18. All right, so HO and H1, okay. For some reason, this thing come here, it will change HO and H1. So our HO will now be, if you look at this thing, it says here that a report, a research report that the average salary of assistant professors in the year 1997 is more than 42,000. See, that is that will give you an idea of where to put the claim. Now, more than means greater than, and you can only use greater than in the alternative. You can only use greater than symbol there. So you're gonna put mean, okay, is greater than, what is it, greater than symbol, $42,000. That's a claim. The alternative hypothesis says that mean is always say the opposite of the null hypothesis. So you're gonna say that mean is it was supposed to say mean is less than 42,000, but the problem is that you cannot use greater than symbol. I mean less than symbol in the null. You can only use less than or equal to, which is what we're going to be using, which is this one here. 42,000. Okay. And your alpha is 0.05. You can see right here, 0.05 is the alpha. So your alpha equals 0.05. Okay. So the main thing is now to answer this, to be able to conduct this test, first thing is to write out the summary statistics. Okay. Like this. So let's put the alpha is this. Sometimes they give you a raw data. I'm sure you're gonna handle it, when you say give raw data. So you say that the sample population mean, which is mu, is 42,000. And then the standard deviation is 5,230. Okay. Now the the sample mean, you see that they collected a sample of 30 assistant professors. So N is 30. Part out of this 30, sample mean X bar is 43,000 X bar. Okay. Yeah, S bar right here. I'm gonna put the bar on top of it. So I don't know how to draw this. Okay, let me correct it. Let me make this things bigger so that we can okay. Drop it. Okay, let me make this things to be bigger. Okay, so we can now yep. Now I can have that S bar is S bar. Let me put the bar on top of it. I'm gonna be careful. So right here, X bar equals, according to the equation, out of this 430 assistant professors, the sample mean for that, their sample mean salary is 43,000 260. So now you have your summary statistics. I'm gonna write them down here on paper, so we can now go and do the test. Run the test. Now you have the option to use the formula, but to save you to make it easy for you, we're gonna use Excel. We have a mean equals some population mean is 42,000. Standard deviation is 5,230. Sample size is 30, and sample mean is 43,260. Okay, let's go and put it there and run our tests. Take it to Excel now. So you can see the question. What question is this? Z test. So we have observation. So now Excel actually doesn't have the Excel data statistical two-pack doesn't have the option for doing one sample Z test, but we're going to trick Excel to do it. We're going to use a trick on Excel. And how do we do it now? It said that the sample mean, population mean is 42,000. Sample mean is 43,260. Okay. Population standard deviation is known as 5,230, and sample size is 30. So to trick Excel to do it, we're gonna put 30 observations here, 1 all the way to 30. Okay. So 1, I'm gonna just use Excel to generate it. So plus 1. Okay. Then I'm gonna copy it so you can get 30 observations. So I said have the analytical two-pack has the option for two sample tests, but not for one sample Z test. So like I said, we're going to trick Excel into doing this test. So by just doing what I'm doing now, sample size. Then for data, we're going to use the sample mean here, 43,000, 260. So for each of this observation, we have this for the sample mean, put it all the way down to the 30th. Okay. Now, to trick Excel, we add a dummy variable so that Excel will be thinking that this is a two-tail test, that is a two-sample Z test. So we put a dummy. For that dummy, put 0. Okay, 0, 0, at least 2 places. Then now you're ready to run the test. Okay. Now we have the click on data analysis, and it will bring it up right there. Go all the way down to the last option, which is Z-test to sample for means. Click on it, and then click on OK. Okay. All right. Now for the variable range, variable one range. Remember, Excel is looking at it as two sample Z-tests, but it's only one sample Z-test. We're just trying to tweak it with the dummy variable. But for the variable one range, use the data here, which is the admin salaries, right? So I'm gonna highlight all the way to the last one. That's it one. Okay. Now for the variable two range, we use the dummy variable here, just stops here. Then for the hypothesized mean difference, remember they said that the mean, population mean is 42,000. So that's what we're gonna use, 42,000. Then for the variance, variable one variance, so what we gave us in the question was is the standard deviation, but Excel is giving us variance. So we square the standard deviation to get the variance. If you're given the variance, you find the square root to get the standard deviation. But here they give us the standard deviation to get the variance. We just square the standard deviation. This standard deviation is 5,230. So let's go and square it. All right, it's now 5,230. I have it here. You can square it and then put it right here. With Desmos calculator, 5,230, square it. Give me 27,352 900. Okay, let's go and put it in Excel right there. We got 27,352 900. Now for the variable, okay, for the variable, you know, 1 minute, let me make sure what's going on here. Okay, Erwin, Erwin. For the variable, you know, for the other variable two variants, that's for the dummy variable. For dummy, if you put 0 here, Excel will not accept it. So we put a number that is very, very small, that is basically 0, something like 0.00001. If you put only 0, because you know that dummy variable here is 0, Excel will not accept it. So 0.00001, which is basically 0. Now, since when we are collecting this, when we are taking this, we also checked the data, their names. So I'm going to check the label right here. And this test actually is let's say this, the alpha we are using. Alpha is 0.05. So it's already 0.05 by default. So I'm going to put it right there. Okay. I'll click on this. Click on this, okay, so I can share it properly. Okay, so you put it's already 0.05 by default. Now the output range is where we want it to be located. So I'm going to click on this. Output range, I'm going to click on this and probably place it right here. And then since everything is in, we can just click OK. You give us the result. So you give us the result at two sample Z-test. So the part with the dummy, you delete it. Okay, delete it. Then rename it. See, it gives it to you as a two sample test. Rename it as one sample. So we have tricked Excel into doing the one sample test. Then change this, remove this hypothesize mean difference, remove the difference sign, remove the difference. Then we're gonna put this together and then copy it and paste it in our main workbook so that we can now make our decision whether to reject or not to reject hypothesis. Okay, we come to Control C, copies it. Now we go to our workbook and paste it there so we can make our decision. Okay, I'm gonna move it down a little bit. Okay, make sure I've seen this. Yeah, seeing it will be good. So I'm gonna make it bigger. Okay, so everyone can see 16. Good. Now you can see what we need to use here. The critical value, based on our result, the critical value equals now alpha is 0.0. This is, you can see that this is greater than, so it's pointing onto the right side. So it's a 1 tail test, right tail test. So our critical value would be right here. So you can see where you have critical 1 tail. It's right here. 1 tail gonna be right here. 1.6 for basically 1.65 gonna be, because if you look at the value in Excel here, Excel, if you round this up to 3 decimal places, excuse me, my mistake. See, if you round it to 1 decimal place, see, I say it's 1.645. Okay, 1.645. That's why it says is, if you look at that, because of that, you're gonna be 1.65 here. 1.65, that critical value. 1.65. So I'm gonna highlight it. So 1.65 is the critical value. 1.65. Okay. Now calculated value for test statistic, calculated Z value equals, you'll see right here, Z equals 1.3, 1.32. If you round it up, that'll be 1.32. Okay, 1.32. 1.32 right here. So you have 1.32. Now, decision criteria. Remember the decision criteria. You reject H null hypothesis if the calculated value is equal to or exceed the critical value. You look at our answer here. Is 1.32, but it is less than the critical value. So the conclude decision now becomes decision maybe equal to do not reject HO since the calculated Z value of 1.32 is less than the critical value. Okay. And then we can say this, if you're using the p-value, if you look at alpha is 0.05. P-value that we have here is right here, 0.09. See? 0.09, which is bigger than 0.05. In that case, you don't reject. Because for the p-value method, it says that you reject. It says if the p-value is less than or equal to alpha, you reject. If not, don't reject. See? So whereas for the critical value, if you're using the critical value method, if it's bigger than alpha, if it's bigger than the critical value, if your answer is bigger than the critical value, you reject. Otherwise, don't reject. So anyway, we didn't reject. So we did not reject the null hypothesis. That means that the claim is not we don't have enough evidence to support the claim. So that's how you can state it. So you can state it this way that there is not sufficient evidence. Okay? We don't have sufficient evidence to support the claim that assistant professors make more than $2,000 a year in 1997. So that'll be like a conclusion. Okay. Conclusion. There is insufficient evidence to support the claim that assistant professors earned more than 42,000 in that year. Okay. Any question on this? Okay, no question. So let's try another one then. That is basically how you do it, but let's try one more against this one as well. I mean, remember you have option to use the formula methods. You want to make it, but this one makes your life more easy. Yeah, it says here the Medical Rehabilitation Education Foundation reports that, excuse me, here. Oh, okay. Anyway, the Medical Rehabilitation Education Foundation report that the average cost of rehabilitation for stroke victims is 24,000 672. To see if the average cost of rehab is different at a particular hospital, a researcher select a random sample of 35 stroke victims at the hospital and find that the average cost of their rehabilitation is 25,226. The standard deviation of the population is 3,251. At alpha 0.01, can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different from 24,000? So he said is different. He said, can it be concluded that it is different? Yeah. It's different is not equal to. Then it didn't tell whether it's greater than or not greater than, but you just say it's different, which is something as saying not equal to. So that's okay. Now, first thing, of course, as you know already, is to state no hypothesis and identify a claim, solution. Okay. HO and H1, of course. H1. Okay. Now it says can it be concluded that the average cost of rehabilitation is different? So not equal to can only be used in the alternative. So I'm going to make mean not equal to what is it right here? So for 24,000 Yeah, 672. Now, so the opposite is the north say the opposite of alternative. So it will mean equal to that. Mean equal to let me put it right here. Equal to 24,000. 24,672. So this one is say that it's different. Can it be concluded that the average cost of stroke rehabilitation at a particular hospital is different? So it's different, that means it's not equal, and that's where the claim lies. Okay. So now I'm gonna upload this. It's not shouldn't be bold. And alpha is alpha right here. 0.01. So now let us write out the summary statistics. Say the Medical Rehabilitation Education Foundation report that the average. Now, before I do that, this is equal and not equal. That means it's a two-tailed test. So the average cost is 24,672. So we have it here, mean. I'm just gonna copy it and paste it here. So I have our summary statistics. To test this, they selected a sample 35 stroke victims. So N is 35. And the standard deviation is you can see right here, 3,251. Standard deviation equals 3,000. That's right here, 251. 3,251. And this for standard deviation. No, for that sample of 35 stroke victims, the annual salary, average cost is 25,226. So I have a sample mean X bar. So I'm gonna put X bar. You have to put a bar right here. Okay, X bar is 25,226. So let me write these things down so we can go and get the test statistics. Excel mean is 24,672. Okay, and alpha is sorry, a mistake. N is 35. Standard deviation is 3,251. Okay. Then what else? What the sample mean X bar is 25,226, and alpha is 0.01. Let's go and put in. The good news is that we have already used this thing already here. All we need to do is to change it and it will calculate it for us. But in any case, I can just take this observation. Oh, excuse me, make sure I've seen it. Take it to Excel. More time. So you have observation. So we're going to click Excel again. Okay, and we have data. I'm going to use dummy to trick it again. Variable. And this we can just copy this titles here and paste it by the side. So we can now use them. Put them right here. I can just put them here. Okay. Good. Now, how many sample size for this one is N is 35. So we're going to go to all the way to 35. So the division, I'm gonna do 1. Then put click on this. Yeah, put equals, click on that, +1. So you can get 35 easily. So I just drag it down. Oops, 35. And it's 35. I'm going to bring it back a little bit. For the dummy, put at least 2 zeros. At least. Oh, sorry. This for the data. For the data, remember we are told that some population mean is 24,672. And then that the sample mean X bar is 25,226. Then the population standard deviation is 3,251. Remember, it is right here. You can see right here, 3,251, and I have it here as well. So, but this thing will be asking for variance. I'm gonna put it there anyway. Let's put it 24. So that's 2,000, 3,251. Okay. Sample size, and it's 35. You can see 35. 35. So now this population mean is what we're gonna so the sample mean, say S bar, so say 25,226. I'm gonna put it right here. 25,226, because still out of the sample, okay, 35 people selected. So I'm gonna copy it down here. Okay, copy it down. Do it all the way down to the last 35. Okay, good. Then for the dummy, I just put 2 dummies so that Excel we're thinking that it is doing a 2 sample test. So we're gonna trick it again to do 1 sample Z test. Okay, we have observation data and dummy. Okay. Now let's just run it. Click on data analysis. Go all the way to the last one, which is Z test 2 sample for means. Okay. I'm going to remove all distance that I used before. Okay, I'm going to use all of them. Okay. Let's go down to where we are. This is where we are. Now I'm going to put this one there. For the variable 1 range, just put the data. The average salary, right? Okay. For the dummy, for the variable 2 range, put the dummy variable. Then hypothesize difference. You put your 25,000 24,000. Remember, it is right here. It is right here. And this hypothesis 24,672. I have it here as well. So you can go and put it right there. Yeah, okay. So you can see it now. Got 24,672. Okay. For the variance, for the 1 variance. So remember the variance is 3,250. Sorry, what they give us is the standard deviation, which is 3,251. So but we're using the variance, so we gotta square it. So we got at this place, well, the calculator. We got 3,251 squared. So when I write this down, that's what we're gonna use. 10,569,001. So let's go and put it there. Okay. But okay. All right, let's see. Let's put it right there. Okay. So we have 10,569 001. Just double checking. Let me check it again. 10,569 Okay, good. It should be in Excel. In Excel, okay. Should be there. Good. So now for the variable 2 variance, that means for the dummy variance, we can't use 0 because I said we'll not accept 0. So I'm going to just use a number that is very, very small, that is basically 0, 0.00001. Then they want us to use alpha of 0.01. So I'm going to change this alpha to 0.01. I'll check the label because I thought I included this when I was making selection. Now the output range, we can put it right here. Then we please OK. Yeah. Now it gave us to us instead give it to us as a two sample test. So we're gonna remove the dummy part of it. Okay. So and then rename it to one sample test. So I'm gonna remove the dummy part of it. We use the trick Excel. Now I'm gonna rename it to one sample. And then you have the remove this difference here. See difference. Size mean difference, remove it. And I'm gonna just format it properly. Now remember this one. This is the p-value for for this p-value. Actually it's the this for p-value for 1/3, but this is the p-value for 2/3 right here. And I have this right here. I'm gonna highlight it. Now this is test statistics right here. I'm gonna highlight it. But that's what else you have. But if this is a 2/3 test, if you remember, equal or not equal to. So I'm going to highlight the critical value as well. So we use the p-value of the critical value to reject or not to reject. Z critical for 2/3 right here. Now remember, if you round this round it up to 2.58. Okay. So I'm gonna format it and then Control C, copy it out and paste it here into the your main workbook. It's right here, so you can make our decision. Paste this right here. Now, not enough room here, so I'm going to move it down. Okay. So now we're ready to make our decision. Okay. So let me expand it. Make it 16 should be enough. Let's expand it a little bit. So now they make a decision. They calculate critical value. Since this is a 2/3, a critical value equals from here for 2/3 2.58. Calculated value What the value is right here. See 1.001. You can see right here. See 1.001. 1.001. So let's make our decision. This is come under our decision. Okay. So now our decision then becomes since the calculated value is less than the critical value, we don't reject. Do not reject HO. Okay. So if you don't reject HO, that means the claim is correct. Sorry, the claim is not correct. See, this is the claim that the average cost of stroke rehabilitation is 24,000. 24,000 is different from 24,000 672. So it's not. So answer is that there is not enough evidence. Conclusion. There is insufficient evidence to support the claim that what is the claim? That the average cost is different from this. Yeah? That the I'm gonna make it 18. Okay, 18 is good. Yeah, and that's it. So if you're using p-value method, then you look at the p-value, and the p-value is right here. The truth is 0.3138, which is bigger than alpha. So when it's bigger than alpha, you don't reject HO. And that's how to do it. That's how to do run the test. Do hypothesis testing. So now, but any question before we do z-test for when this the sample size is small, like here when we do a test for the mean when the sample size is small. That case, we use what we call the t-test. Okay, the t-test for the mean. So any question in the one we just did before we can go to the t-test. Hello, guys. Any question, guys? Okay, so no question. Good. Now for t-test for the mean, we use it when the population is normally or approximately normally distributed. The population standard deviation is unknown, and the sample size is small, which is when the sample size is less than 30. Again, we use something formula similar, which is t. This time around, we use t, s bar minus mean over standard deviation over square root of n. Unfortunately, Excel doesn't have a way of tricking it to use the summary statistics. So we're gonna use the old school method to get this one, and it's based on what they call the degrees of freedom, sample size, and degrees of freedom. So t equals to x bar minus mean over standard deviation. We use s for that, divided by the square root of n, where s bar, as usual, is the sample mean, mu is the population mean, s is the sample standard deviation, and then n is the sample size. So the degree of freedom, we get it by doing n minus 1. Okay, they can get the critical value. Let's try this example here. It says a job placement director claimed that the average starting salary for nurses is in 2000 is 24,000. In the year 2000, 24,000. A sample of 10 nurses' salaries has a mean of 23,450. And the standard deviation of 400. Is there enough evidence to reject the director's claim at alpha 0.05? So what we're gonna do here is, again, start by stating the hypothesis HO and H1. I'm going to make this here to be 18. Said, is there enough evidence to reject the claim? He said the claim is that the average starting salary for nurses in 2000 is 24,000. Is means equal, so we can only use equal in the null hypothesis. So that means our HO is mean equal to that. Okay, of this mean right here equals 24,000. Here, a sample of 10 nurses were selected and has a mean of 23,450 and the standard deviation of 400. Is there enough evidence to reject director's claim? So now, this is our claim here that the mean salary for nurses in the year 2000 is 24,000. So this is the claim right here. This time around, the claim is in the null hypothesis. Alternative is mean is not equal to that. So you got mean is not equal to that. What is it? Okay, if it's not here, then I have to get it from the other one. Because we did, oh, you know what? Not equal. It should be here. Okay, let me see if I can see more symbols here. Not equal to right here. Okay. Not equal to 24,000. Okay. Mean equal to 24,000, mean not equal to 24,000. Let's see. Okay, this is yep. I'm gonna check some few things. Yeah, 24,000. Anyway, now because I said it doesn't have the option of doing this, even it is a t-test, which is based on the profit of. So we're gonna use the OSCU method. Our alpha is it's right here. Our alpha is what that is. So that we can get our critical value. Now I showed you these formulas. Yeah, I'm going to put it in the model so you can download it and print it out right here. These formulas. So I'm gonna put it on the model so you can download it. These formulas here. So because you need to find critical value if you're doing the t-test. So the critical value to find out, we use this formula that I have there. So I'm gonna type it in here so you can see it. This is obviously a two-tailed test, okay? This is equal to and not equal to. So we're gonna use this formula in Excel to get the critical value for the two-tailed test. And for T, this is a t-test. Two sample t-tests. Equal, this is the formula we're gonna use. Equal. Make sure I've seen this. Yep, good. Equal okay. T dot inverse dot 2T because it's two tests. Then make parentheses alpha comma alpha comma alpha comma then degree of freedom. That's all you need. Let's do it for this one. we go to Excel. Alpha is 0.05. Okay. So we go to Excel and get it, then we can come back here and put it in. So you have alpha t dot inverse dot 2t. Okay. Alpha show up as 0.05. Okay, alpha 0.05 with how many degrees of freedom? Let's get degree of freedom for that question. Here the sample size n equals how many of them were selected? 10 nurses. So the degree of freedom df equals 10 minus n minus 1, which is 10 minus 1 equals 9. Yeah. So let's put this in 10. Back there. 9 degrees of freedom. Close it. The enter key. 2.262. Okay. Yeah, 2.262. Now I write it down. 2.262. We've got the plus or minus. Simple. Let me go just call it 2.26. Yeah. 2.26. So Christopher value equals 2.26. Okay. Now, other things that you need to know is the mean. That mean is this. Okay. Here. And then n is 10. And the standard deviation is this time we're using sample standard deviation S equals let's see, sample standard deviation S is $400. I'll get a good degree of freedom. We have an n. It means the sample mean x bar. The sample mean x bar. Good. You have to put the x bar right there. Okay. It's sample mean is a sample of 10 nurses have a mean salary of 23,450. 3,450. So you have all the small statistics we need to do this around this test. So we're going to be using the formula for this is the formula we're going to be using here. Okay. Now, S-bar minus B was sample standard deviation. So let me write this thing down so we can go and get them Excel. I mean, with the calculator. I got mu is 24,000. Sample size is 10. Sample standard deviation is 100. Okay, X bar 23,450. So at a degree, I think we got everything we need. So let's run the test. I'll take it on our book so you can get it on using formula. Excel doesn't have that. What we just did for Z test. Excuse me, I don't see it in Excel. So we're gonna do it the old school way. Okay. Now we have so we have T, not T, small T. Yeah, we'll make it bigger. Okay, T equals, excuse me, X bar plus x bar. Right here. And our mean is right here. Divided by standard deviation, sample standard deviation for the square root of n. Okay. N, which will give us, put this right here. We have everything written down. S bar, as you can see, just to refresh your memory. Let's look at this right here. So it's formula. So let's go to this and refresh your memory with these numbers that we need to put there. Okay. You see right here. Some population mean is 24,000. Sample size is 10,000. Sample standard deviation is 400, and samples mean is 23,450. Let's go and put them in. Formula there. So put the formula there, and then open there. Have equals sample mean is 24, 23, 450. Some population mean is 24,000. Then sample standard deviation is okay, sample standard deviation is 400, but the square root of n. So n, and n is 3,450. So let's write this down. I can get it out. T equals 3,450 over 400. Scale top 3,450. Okay, let's go and put it in the calculator. Answer. We got 23,450. No, 24,000 divided by 400 over square root of 23,000. $450. Okay. What I miss here? Oh, 23,450. So give me let me see what I'm missing. Yes, 20 square root of n. Oh, square root of n, my mistake. N is 10. My mistake. Sorry about that. N is 10. It's not showing here. Okay, let me see why it's not showing. N is 10, not N is 10 right here. N is 10. I put it on like this. This should be 10. So I'm gonna let's go and put it right way in the calculator. make sure. Okay. Negative 4.35. We'll put the negative 4.35. I'm gonna copy this and then paste it right there. Paste it in the main workbook, which is right here. So have this. Yeah, put right there. Move it down. Okay, let's see here. I can just move it down. It's also got 4.35. We can now make our decision. We have the critical value, we have it as 2.26. 2.26. Critical value. Point 0.26. Okay. Then calculated value. Equals, answer we got is negative 4.35. Negative 4.35. So what are you using? Actually, we're using the absolute value of that answer. So when I use the absolute value of this, I know that absolute value of this would be like like it's like it's drawing two lines here and here. Okay. Okay, let me let me clean them. I'm gonna tell you what I mean by that. Okay. Yeah. So I just shift this a little bit. Should have seen this. Yep. So after the value of this would be, you're gonna use this to draw it. So you're gonna make a line here and here. So the absolute value is 4.35. Yeah, now we can make our decision. Our decision is to reject HO. HO. And you can see that HO is right. Is what the claim is that the salary of nurses, the starting salary of nurses in 2000 is in the year 2000 is 24,000. So we don't have enough evidence to prove that. Conclusion. There is insufficient evidence. Yeah. Insufficient evidence to support the claim that what the claim was that the starting salary of nurses, the average starting salary of nurses, okay, is 24,000. And the average starting salary is more than 24,000. Insufficient. Any question on this before we round up? Okay, no question. So now, when you get a chance, you can try one of any of these. I think I have three on the other side. Like we have this ones. Okay. Now for this one here, this type, just find the mean and the standard deviation using Excel, and then follow the same method that I just described in this video for the t-test to get the t value. Okay. Any question before we round up? No question. So, guys, I'll like I said, I'm going to make the final exam available on Sunday night. There's no classwork tonight, so just this video you can watch it and use it as a guide to do your homework on the homework 9. And I also have these videos on this already presented before. You can even use that one if you prefer that one. And then there will be a project will be available in the morning. Sorry, tomorrow. And then I wish you the best. Okay.
Excuse me?
Class is over. You have any question for me?
Yes, can I ask after in private?
You,
Have you already taken attendance?
yeah, I did already.
Okay.
I just have one question I want to ask
Yeah, ask. I'm here.
after everyone leaves.
Did you send me email?
Yes, but I need to ask you a question if that's okay.
Okay. So guys, you are free to go. So I
Hi,
can't
sir.
be,
I just didn't hear my name get called for attendance. It's Janiyah Seabrook.
I didn't call it. I just was taking it as you guys are coming. What's your name?
Oh, okay.
Have a good
Thank
rest of
you.
the week,
It's Janiyah
Dr.
Seabrook.
Joseph.
Say one after the other, please. What's the name, ma'am?
Seabrook is the last name.
Oh yeah, I have your name already here.
Okay, thank you.
Welcome. All right, then
Hi, Professor. I think last week you marked me absent. I'm just not
what's the
sure.
name? What's the name again?
Savannah Irvin. My last name starts with an E.
Yeah, you're correct. So I'm gonna correct it then.
Okay, thank you. And are you still doing the assignments to open up?
You have last week was the deadline. Well, actually, it was deadline. I extended it to last week. You haven't sent yours. If you have to 70, do you have up to 70?
I'm sorry, what was that?
Is your grade in attendance up to 70%?
It should be, yes.
No, well, if it's this, then
Because I think it went down when you marked me absent last week. It went down to 67 from 70, I want to say.
then check it today again after I marked it because I can't after today. If you don't send it today, I can't accept it tomorrow. Okay.
Okay.
All right, guys. Have a nice day. Let me see.
Thank you, you too.
All right. So got my gas attendance. Didn't show up. Yeah, sir. You have to ask the question because I have another class.
Yeah, everybody's
Another,
staying, even
so
though
I
class is
can't.
over.
Huh?
Yeah, I just emailed you. I'll let you know. I had a bit of an emergency happen, so I had to go to the doctor and the dentist and everything. And I think I sent you my doctor's note, but you gave me my 5 assignments that you extended, and I did 3 out of the 5, and I was supposed to have it in by May 3rd, which is Saturday. But when I was doing them on Saturday, I had my situation. So, and I think I sent it to you in my email. So I wasn't able to complete them. So I was just going to ask if I could have an opportunity to send them to you tonight.
Yes, do.
Okay, thank you. And also,
Hello.
just in general, because so the way it worked is with the makeup assignments, I was going to get my grade up to like a high 80, and I would have had a solid chance of finishing with an A. But I ended up missing 2 assignments, unfortunately. And so it kind of just ruined the whole situation for me.
I can't. I remember I said it's 5. I can't go
Yeah,
beyond.
no, I'm not asking you to let me do them. I'm just wondering, like, if I do these 2 assignments, I obviously want to at least pass your class because I think I should. With the assignments we have left, I guess with the final as well, is there a solid chance to, well, you don't know my grade. I don't know. I
Yeah,
wish this was
see, the thing is this, I can't even tell you because each of them. I would recommend you go to the syllabus. Each like you have test, homework, classwork, project, and final.
Mhm.
So each of them have weight. So when I put your grades on the makeup, they will all calculate. As I wouldn't know what they will calculate to. But when I put it, they will calculate depending on your grade on it. If your grade is good, it will push it up. How far is it gonna push it up? I don't know. See what I mean? So
Yeah.
hmm, it depends on
I'll
your.
email you. When you put the grades in, I'll email you.
All right. All right, thanks. I'm gonna let you go now.
I'm gonna send you the assignments tonight.
Yeah, email it.
Okay. Okay.
Don't forget, I put my email address on it. So you
Yep.
got
Okay.
not don't send me email from Canvas. Just send it to that. Log into your school email, type my email, attach them, email it to me.
Okay.
All right,
Thank you.
you're welcome. You did the homework part, right?
Say it again.
The homework part, the one in Canvas, you did that one too, right? You did that one?
Yes, I did those three. You gave me three.
Yeah, I put okay. Good.
Yeah.
All right. All right, guys, I'm gonna let you go. I gotta go now. I really have to leave now. I close this.